Welcome back, everybody. Hope everybody's doing all right. It's really quiet in here. Like it's awkwardly quiet.
I'm so tired.
Is that what it is?
Yeah.
Baker's tired, so he's not talking, so nobody's talking. Anybody, I was gonna say anybody doing anything fun yesterday, but like. Got anything interesting going on?
I had some basketball practice. I was playing Madden.
You did your math homework? That's always fun.
I was bored. So then I went digging, kind of etch a sketch, instead of drawing with cool stuff.
You went digging?
Yeah.
Like outside digging?
No.
Or like through your old stuff? Oh, God. I watched the basketball. I watched the girls' basketball game. Nice job, Frank. Watch that one. Yeah.
I drove for 10 hours.
Welcome back.
Yeah.
Where were you?
Georgia and Florida.
You're fun.
Yeah.
Did you visit family?
No, we just bought a house in Georgia, so we were looking at it.
Are you moving down there permanently?
Yeah, after this year.
Oh. It'll be a little bit warmer down
Yes.
there. Tiny bit warmer.
Not too much.
Sorry. The video's working. Everybody at home, make sure you're doing the warm up right now. Okay. So let's take a look here at this warm up. How do we check to see if something is a solution?
You plug the Y's into the Y's.
And the X's into the X's, right?
Very nice.
So that means this X comma Y pair that we have is going to look like this. We got 1 is less than 2 times negative 2 plus 4. So this is going to end up being 1 is less than 0. People, is 1 less than 0? No, 1 is not less than 0. 1 is greater than 0, right? So this is not a solution. Not a solution. All right, now, is number 7 set up to graph yet? No. What do we have to do to it? Divide by negative 1. Okay, we have to be very careful here. I divide by negative 1 and everything gets divided by negative 1. Now, normally that would just switch out all the signs on the other side, and that's what it does. I've got an X and then a minus 4. What thing do we have to be careful about now? The symbol, right? Flips the symbol. Less than turns into a greater than because we divided by a negative with an inequality. We must flip the symbol. All right, so that means I go to my graph. That slope is a 1 and the y-intercept is a negative 4. So I go down here at negative 4. I plot my point at negative 4. That's my b value. That's my y-intercept. And then I use my slope of 1 to generate more values. Up 1 over 1, 1 over 1, 1 over 1, and so on and so forth. So we've got all those dotted lines. Now, do I make this a solid line? Why not?
Because it doesn't have the or equal to.
Right, the or equal to would mean that it would be a solid line. Remember, or equal to is kind of like that closed dot. That would be the solid line. It doesn't have that. So I'm just going to make it a little bit more evident that it's a dotted line. And now I have to decide where to shade. Do I shade above this line or below this line? Can you tell me? Do I shade above this line or below this line?
Below.
Why do you say below?
Because it felt right.
It felt right. I just said below and it felt good
Yeah.
in my bones. Yeah.
Above.
A greater than means shade above. Well, because here's why I ask, because this is a difficult one. Because people would try to tell me shade below because it's less than. But didn't my symbol switch? My symbol is no longer a less than, it's now a greater than. So I do not shade below, I actually shade above this line. So let me go in with a highlighter here. Shade above this line. Questions about that? Now, what does that mean? Let's kind of talk about what does that mean. What is that shaded area?
Everything that's shaded.
Good. Everything that's shaded would be a solution. Every location on there, if I pick out any coordinate that's shaded, that would be a solution. So should 0, 0 be a solution? Yes, it's shaded. Should 5 comma negative 5 be a solution? No, it should not be a solution because it's not shaded. 5 comma negative 5 would be down here. That's not in my shaded region. If I plug that in, that would be a not true statement. That would be a false statement. Not true. False. Questions about that? All right, let's take out our homework and kind of check our answers. You're going to see for a lot of this graphing stuff, again, it's a lot of me just showing you the key and checking answers. So here's 12, 13, and 14. You should get a no, yes, no. And then you see the two graphs for 15 and 16. Mm-hmm. 12 is a no, 13 is a yes, 14 is a no. And then we see 15 and 16. 15 should be a dotted line shaded above. Check and make sure you have the correct slope, that it's going down and to the right and not up and to the right. Number 16, you should have divided by the negative. That's why I'm shading below the line. Y-intercept is 0 because it doesn't have any plus or minus up there. This is kind of like a direct variation. The y-intercept is 0. The slope is -2 going down and to the right with the negative slope going down and to the right. Here is 17 and 18. Go ahead and check those graphs. Both of these, and including 16, we're all solid lines. Again, please make it very evident whether you want it to be a solid line or a dotted line. I don't want to have to guess at that. Number 17, you should have gotten y is less than or equal to negative x plus 2. Y-intercept of 2, slope of -1. So that's why you see up here positive 2 going down and to the right. Number 18, you could have just added the y over to the other side, but in my case here, I subtracted the x and divided by -1. So you got a y is less than or equal to x. So shading below that line. And let me flip it over to the other side here. Here's 20 and 21 and 29 and 30. Again, I wanted to talk a little bit more about 29 and 30. Remember that any y equals line is a horizontal line, and any x equals line is a vertical line. So when you're talking about inequalities, this y is greater than 1 is really just like a horizontal line. Because the slope is 0. If you think of it as like y is greater than 0x plus 1. It's a horizontal line at 1. Dotted line because it's not an or equal to. And then we're shading above. Okay, remember, y equals horizontal, x equals vertical. So that means -2 is less than x, which is kind of like x is greater than greater than -2, right? So remember that x is -2 is a vertical line at -2. So it's just a vertical dotted line. And since it's greater than -2, I'm shading everything to the right. I bet some of you guys did it on a number line. Yeah, because that's kind of like what we've done before. Still got this example up here from 8th period yesterday where we, just had one variable. Okay, questions on the homework. What would we like to go over? Anything? Going once? Going twice? Okay, here we go, folks, into section 6.6. Solving systems of linear inequalities. So remember when we got into chapter 6, we said, okay, a system of equations is just basically two equations on the same graph. Guys, what was the solution to a system? Visually, what was the solution to a system? Just think back before break. If I've got two lines on the coordinate plane, what was the solution? The intersection point. Good. The intersection point. And we spent a long time trying to figure out the intersection point. Okay? But that was two lines. What if we make them two inequalities? tendency is to think, oh man, that's going to make it a lot harder. Actually, it kind of makes it easier, folks. If we make them two inequalities, keep the phone away, person. Get off Snapchat. Jeez. I'm going to put you in the front so I can watch you and your phone. If I have a system of inequalities, it actually makes it a little bit easier because, there's not just one solution. All you're basically going to do is just shade both parts and see what happens. Okay, first off, how do we start all of these things? Well, we start by saying, we start with the definitions, I guess. System of linear inequalities is basically two or more inequalities with two or more variables. The solutions are where the things cross, right? Where the lines cross. But if they're not lines anymore, if they're inequalities, it's basically where the shading crosses. The whole region where the shading crosses. So how do you tell if something is a solution or not? Well, how do we tell every time something is a solution? You plug it in, right? So let's do that. Let's see if this is a solution. Now, for a system, I've got to check both things. So I'm going to plug x comma y into the top one and then into the bottom one and see what happens. Okay, let's do it for the bottom. For the top, Negative 3 is less than or equal to negative 3 times negative 1 plus 1. So we've got negative 3 less than or equal to 3 plus 1. Is negative 3 less than or equal to 4? Yeah, that checks out. Okay, good. Let's check the bottom one then. Negative 3 less than 2 times negative 1 plus 2. Negative 3 less than negative 2 plus 2. Is negative 3 less than 0? Yes, that checks out as well. So, is negative 1 comma negative 3 within the solution region? Yes. Yes, it is a solution. Okay. Questions about that? All right, let's take a look here. Let's try our next one. Let's try part B. Example 1B. I've got negative 1 comma 5 as my x and y, so let's plug it into the top. 5 is less than negative 2 times negative 1 minus 1. So 5 is less than 2 minus 1. 5 is less than 1. Is that a true statement? No. And at that point, I can stop. I don't even need to check the second one. This is not a solution.
You just put no.
Sure. Because the question really is it a solution? Yes, hey.
Can we put the little symbol with the circle line through it?
Sure. You can put no bueno. What's 9? 9. It's gonna sound bad when you do it. 9. Don't put the number 9. Nicht gut. Is that right?
Yeah.
I made that up. What's French for no? No. But you gotta sound correct. You're like, no. You gotta put your hand. Or is that Italian?
Italian.
No, man.
My grandma's Italian.
No. 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 All right, here we go.
The people watching at home are probably disturbed.
That's okay. That's okay. Sorry if I offended everybody out there on the internet. All you French people out there. Yeah, you can deal with it. Not me. So take a look at these examples that I have. Now, this is not in your guided notes, but I just wanted to show you a couple end results here. Do you guys notice how there are overlapping shaded regions? Right? If you've got two inequalities, that means you're going to have two sets of shading. So you're going to have an overlapping shaded region. The overlapping shaded region, that's where the solution region is. Okay? Because it not only has to be a solution for one of the inequalities, it's got to be a solution for both of the inequalities. So it needs to be in both of the shaded regions. It needs to be in the intersection of the shaded regions. So like in this first example here, this would be a solution because it's within both shaded regions. But in this second example, that one would not be a solution because while it is in the shaded region for the one line, it's not in the shaded region for the other line. It needs to be like it would have needed to be in here for it to be a solution for the whole system. Yes.
What if it's in the white space?
Then it's not a solution at all. Then it's like, then that's an example like this, where it wasn't even a solution for either of them. Okay. All right, so let's take a look here at the example that you have here. Y is less than or equal to 3 and y is greater than negative x plus 5. So this is an example kind of like one of the last ones on your homework. Y is less than or equal to 3. I don't know where my graphs so far down there. Come on, buddy. Come back up. Wake up. Here we go. All right. Guys, what kind of line is a y equals line? Horizontal. It's a horizontal line. And where is this horizontal line? 3. So I'm going to put a horizontal line at 3. Is that horizontal line going to be a solid or dotted line? Solid. Now, I would normally at this point shade. But here's what I'm going to do. I think it can get a little messy. By all means, if you want to use colored pencils, go for it. But I think it can get a little messy if there's multiple shaded regions going on. So you know what I'm going to do? I'm going to put little arrows of where I would have shaded this. Like I'm going to shade this below the line, right? Because it's less than or equal to. So I would have shaded that below the line because I need to see where the other one ends up. Let's see where the other one ends up. Is it solved for y? Say yes.
Yeah.
Sweet.
Yeah.
So that means my slope is -1 and my b value is 5. Okay, we go up here at 5. Do I care where the two lines cross? No, not anymore. I don't really care because I only care where the shadings cross. That's where I care about. So there's my -1 slope going down and to the right. Is this a dotted or solid line? Dotted line. And now where would I shade this? Would I shade this above or below the line? I would shade it above. So that means I'm shading up here. Now, look at my arrows. Look at where I would have shaded. I want below the blue line, but still above the red line. So now I can go back in with a highlighter and say, okay, I only want that piece in there. You see that? That's the only place where the solutions are. Okay? Is 0, 0 a solution? No. What about -5, 0? No. What about 6, 0? Yes. Okay, let's try it again. Let's try this one. I don't know why my graphs are so far down there. Come on. Now I left some room here because what do I have to do with this first equation? What do I have to do with that first one? I have to get
You have to get y alone.
y alone. I got to kind of solve it, right? I got to get y completely alone. I got to solve it for y. So let's do that. Everybody do this with me. This is your next one, correct?
Yeah.
3x minus 2y is less than or equal to -2. Okay. Let's solve here. We subtract the 3x. We would get -2y less than or equal to -3x minus 2. Remember, always put your x's first. I divide by -2. What does that tell me I have to do with the symbol? Flip it. 3/2x plus 1. Like 2/2 is 1. It was a negative divided by a negative, so it's in positive 1. So that means my slope is a 3 over 2. And my b value is 1. So let's go graph that. Rise 3, run 2, down 3, left 2 as well. Okay, that's a solid line because it's got an or equal to. And I had to flip my symbol, so this is greater than or equal to. Guys, don't get me wrong. If you wanted to shade the whole thing out, go for it. Like, watch, I'll use smartboard magic here. Yeah. So I want this one to be blue. I'm shading above this line because it's greater than or equal to in the end. Okay. And now I go and I let's graph my other line. I'll put it in red. Slope is 4. That one's already solved for. Sweet. Y-intercept is 3. So I go down 4, left 1. Go down 4, left 1. This is a dotted line. And now I'm going to shade below that line. Okay, watch this. Watch me now. Here we go. Below this line. Oh my gosh, look, it turned green. The overlapping region is green because yellow and blue make green.
Wow, that's so great.
I know, isn't it? Isn't that cool? Smartboard magic. Whatever. You get the idea. If you want to shade the whole thing, go for it. I don't really care. I think it's going to be a little bit less confusing if you only end up shading the overlapping part. Because that's where the solutions are. You may want to say like, oh, 4, 0. Yeah, that's a solution because it's shaded. But it's not in the overlapping shaded. It's got to be within here, like a 1, 3 or a 2, 5. Let's try another one. Now let's go to example 3a. Take a look at that one. Let's do this one together. Okay, let's take my first line here. What's the slope of my first line?
Or -2.
And what's my y-intercept? So I go down here to -4 and do slope of -2. Down 2, right 1, or up 2, left 1. And there's my line. It's solid. Solid. And let's shade below. There we go. Okay, so that's my first line. I graph my second line. I'll put that one in red. The m is -2 and the b is 5. Okay, so down 2, right 1. And this one is dotted. And I want to shade above this one. This is a no solution. Is there any overlapping shaded region? No. So therefore, there is no solution to this. There is no solution to this. Now, just because the lines are parallel didn't mean that there was going to be no solution. Okay? Just because the lines turn out to be parallel does not mean there's no solution. The reason that there's no solutions is because the regions never overlapped. That's why. Not because they're parallel, because the regions never overlap. Let me show you an example like this next one. Let's take a look at the next one here. The slope is 3, the y-intercept is -2. You know, right away I can see from the equations Based on their slopes, I see that these lines are going to be parallel. Look, take a look here. The slopes are the same. The y-intercepts are different. That tells me that these lines are parallel. So my tendency may be like, oh, I bet this is a no solutions. I don't know about that. Let's check it. The slope is 3, rise 3, run 1. Yeah, that's 3. Dotted line here for my blue line. And I'm going to shade above that first line, above the blue line. There we go. A lot of shading. I should make it a bigger highlighter.
Probably.
That's all right, though. And then we graph the next line in red, y-intercept of 6, slope of 3. Oops, sorry, one more. Dotted line here as well. And now I'm going to shade below that line. So just because the lines were parallel, does that mean that there's no solution? No. There are solutions to this. Look, it overlaps right in this little tunnel right here, right? Yeah, the region continues off to the right, but there are solutions. Just because the lines are parallel doesn't mean that there are no solutions. Do the last one on your own. Change homework board. What's that? Yes, because it's like technically a plus 0 sitting here. So my blue line is going to be a slope of -2, y-intercept of 3. Down and to the right, up and to the left, dotted line. Shading above that line. You know, I want to go, well, I'll just shade. Oops. Oh yeah, that's right. I can do like, oh, there we go. That's much better. Okay, and then the red line, the y-intercept, or the slope is -2, but the y-intercept in this case, again, is 0. Let's start at the origin. -2. Works better for these sound effects. And I want to shade above that one as well. So in this case, take a look. That's just that little yellow part is not a solution, but everything green is a solution. So just because the lines are parallel does not necessarily mean that there was no solution. All right, so this quiz that we've got on Thursday is just over graphing single inequalities, and graphing systems of inequalities. And that's it. That's it. Okay? Just a simple quiz. It's going to take like half a period. Tomorrow, all we're going to do is review. We're going to have a warm-up over section 6.6. We'll review a little bit. I'll give you time to work on your homework in class. Thursday, we'll go over that homework and then take our quiz at the end of class. Okay. So long, everybody playing along at home.